Okay, let's take a look at page 13. On number 5, did you notice something really cool with your table? That's right. The input of 2 could go to 3 or 7 or 0. Just because I know my input, my output is not determinable. If I know my output, I don't know my input. So look at the function description. This is not a function. The input value of 2 has multiple output values, which is not okay. Take a look at number 6. When I was looking at 6 in the table and was investigating my input and output, I noticed that to go from -2 to -8, I need to multiply by +4. To go from 3 to 27, I needed to multiply by +9. To go from -1 to -1, I multiplied by 1. -5 to -125, I multiplied by 25. And 4 to 64, I multiplied by 16. How are these numbers related to the number I'm multiplying by? Well, to go from 4 to 16, I have to multiply 4 by itself. So to go from 4 to 64, I multiply 4 by itself 3 times. Same thing for -2 to -8. I multiply -2 times -2 times -2. Looking at that, I said the input cubed equals the output. Cubed means I multiply that number by itself 3 times. Excellent. Number 7. Are all functions linear? Explain why or why not. Take a moment and think about this with your group. Are all functions linear? Are there any linear graphs that aren't functions? Explain why or why not. Are all functions linear? The answer is no. Vertical lines have one x value corresponding to many y values. And you could always replace x values with input and y values with output. Take a look, remind yourself about Table 5. Table 5, these 3 points on a graph would create a vertical line. So are all functions linear? No, because vertical lines are linear, but they're not functions. So let's take a look at number 8, 9, and 10. Directions say, given the function f of x equals 2 minus 3x, evaluate the function for each value of x. So let's look at number 8. 8 says f of -2. F of -2 equals, well, that means to evaluate x when x is -2. F of -2 equals 2 minus 3. Please use your parentheses. -2 equals -3 times -2 is 6. 2 plus 6. So that means the f of -2 is equal to 8. And that's how we'd want to say our answer. Go ahead, finish 9, 10, 11, and 12 with your group. I'm going to give you 4 minutes to finish through 12. Finishing through 12 with your group. Go ahead. 4 minutes. Please pause the video and put 4 minutes on the timer. Hopefully that was enough time to pause the video and for you to finish through number 12. So let's take a look at how we did. Number 9, f of 2/3, or the function of -2/3, I misspoke, I apologize. The function of -2/3 is 4. And number 10, the function of 1/6 is 3/2. Remember, we're just substituting in the value given for x. When we moved on to number 11, which said examine the values from problem 7 and 9, state the domain and range. Domain are the x values and range are the y values. We need to make sure we're using our curly brackets for set notation. We're listing them from least to greatest, and if any of the numbers did repeat, we wouldn't repeat them. And what value of x makes f of x equal to 0? Well, if I'm talking about f of x equaling 0, that's the value f of x. That means y. Remember, f of x is a synonym for y. So let's find when y, or f of x, is 0. When I solve for f of x to be 0, I get x to be 2/3. So 2/3 is our value of x that makes the function equal to 0. What value is this? It's our x-intercept when y is 0. Let's keep going on to the next set of directions. The next set of directions say, let f of x equal x squared and g of x equals x minus 1. Find the following values and show all of your work. So let's take a look. Let's do number 14 first. So 14 says 5 times the quantity of g when evaluated at 3. Remember, g of x is x minus 1. So g of 3 is going to be 3 minus 1. Minus f of 2. Well, f of 2, or the function f evaluated at 2, would be 2 squared. Using order of operations, 3 minus 1 is 2, minus 4, 10 minus 4, and 10 minus 4 is 6. Excellent. Let's do one more together. Let's do 16. F of 1/2 plus g of 2/5. F of 1/2 is the function f of x evaluated when x is 1/2. So that means this is 1/2 squared plus the function of g evaluated at 2/5, which would be 2/5 minus 1. 1/2 squared is 1/2 times 1/2, which is 1/4, plus 2/5, and I'm going to say minus 5/5, just rewriting 1 as a fancy 1. So continuing this problem, I would have 1/4 minus 3/5. I need a common denominator. What's my common denominator? It's 20. So this ends up being 5/20 minus 12/20, which gets you your final answer of -7/20. Excellent. Why don't you go ahead and finish 13 and 15 with your groups? If you finish early, you can go ahead and work on other problems. I'm going to give you 4 minutes to finish 13 and 15. Please pause the video now to finish 13 and 15. Okay, hopefully that was enough time to finish 13 and 15. Let's see how we did. Looking at 13, when I substitute in 4 into function f of x, I have 16, and 4 times 16 is 64. On 15, f of -3, the function f of x, the value for -3 is 9, and the function g of 1/4, the function g of x evaluated at 1/4, is 1/4 minus 1, which is -3/4. Oh dear, how do I divide fractions? I multiply by the reciprocal. 9/1 times 4/-3, which gets you -12. I hope you did well. Let's turn the page. Turning the page brings us to the last page in this lesson, numbers 17 and 18. So let's take a look at what this says. Functions can also describe non-numeric relations. Study each non-numeric relation and its mapping below. Does the relation represent a function? Explain your reasoning. 17 says a student's name versus the color of their shirt. Sam wears red. Joe wears blue. Luis wears red. and Mia wears green. Is this a function? Does every input have its own unique output? Yes, this is a function. Each name has only one color. I can also say each input corresponds to a unique output. And it's unique for that input. You might say, okay, so it's unique for that input. Taking a look at 18, does where a person lives versus the team they root for in college football represent a function? Let's take a look. If you look at the input and the output, does every input have its own unique output? What do you think? If you said no, you're correct. No. The input, California, has two outputs. Someone who lives in California could root for the Aztecs and the Bruins. That makes this not a function. So now I'm going to give you a little bit of time to make a mapping of our class. And you're going to need this for your homework tonight. So let's make a mapping of students' names, first name and last name in your classroom versus their birthday. And I need data from 10 students. So I'll give you mine first. So Mrs. Barr, and that's going to be mapped April 6th. Mapped to April 6th. Go ahead, and I'm going to give you time to collect data from 10 students. Please be kind. Remember, you're going to map names to birthdays. You need to include first names and last names. I'm going to give you 7 minutes to complete this task. When you finish, can you explain if the relation is a function? If you finish early, you can move on to the extension video companies on the next page. So again, 7 minutes to complete, getting 9 more students' names and birthdays, deciding if this relation is a function, and moving on to your extension video companies. Go ahead and please pause the video now and give the students time to finish. 3, 2, 1. Excellent. Hopefully that was enough time. With your mapping, is this relation a function? Yes or no? What did you guys think? The answer is yes. Each person, which is our input, has only one birth date. Which is our output. Excellent. Let's move on to page 15. 15 is an extension about video companies. So we have 2 plans for renting or downloading videos, and I'm going to give you 12 minutes to finish 5.1b. 12 minutes to finish this extension. Please pause the video now and give the students 12 minutes to finish this extension. Okay, hopefully that was enough time to finish your extension. Let's see.